Hello everyone, my name is Rick Ader. I'm VP of Sales at Silicon Creations. We're here at the 59th DAC in San Francisco. We were here last year in December, and now we're here in July, and we're happy to be back. The show is going pretty well for us. Just a quick 5 or 10 minute presentation about our company. It's a bit of a status update for the company. We don't have a specific theme to the presentation except to bring you up to speed of what we're up to these days. So just a few bullet points. We're proven in the 3 nanometer in TSMC, our PLL product line, and I'll go into that a little bit. I want to talk a little bit about our LC PLL offering. We have a new architecture brought on within the past year or two, and we have some nice statistics from that product. Talk a little bit about our SerDes product offering. Supporting up to 32 gigabits per second, PCIe Gen 5. And lastly, a little bit word about our foundry support. We're expanding in Intel and Samsung. And of course, we're very much involved with support of our customers, TSMC customers, so much so that we've won the Mixed Signal IP Vendor of the Year 5 years running. So I'll move on to the next slide. 3 nanometer IP story is quite a good one, at least from our perspective. We have PLLs and oscillators in 3 nanometer today. We have some silicon proven IP in 3 nanometer. This is a bit of a laundry list of the IPs that we have today off the shelf available to provide to our 3 nanometer customers. We of course typically start our portfolio rollout in new process nodes by developing and porting and optimizing our fractional PLL product line. Alongside that, we typically introduce a low integer PLL, core voltage PLL. Also have an IoT PLL for IoT devices for low kilohertz level input clocks. And then we also have what we're calling clocking solution IP, sort of expanding the portfolio of our IPs serving the clocking space on your chip. So CML buffers and MUX for clock distribution. And we also introduced a relatively new product called our frequency generator, targeting dynamic DFS, dynamic frequency scaling. That is also in 3 nanometer. We've had that product since 5 nanometer in TSMC. So that's a quick rundown about our 3 nanometer activity. Moving on to the next topic, I mentioned that we have a LC-PLL. We've developed and presented or delivered to customers LC-PLLs for at least 5 to 10 years now. But what's different about our LC-PLL offering now is it's highly digital, and we're achieving some extremely great performance numbers as low as under 400 femtoseconds for broadband jitter. So we have this in 6 nanometer test chip. So we have silicon proven IP here in TSMC 6 nanometer. The area is extremely small at 0.1 millimeters squared. And we're actively porting this into TSMC FinFET nodes such as 1216. I think we have a little picture here of some of the measurements we've taken from this test chip. As it states, we're looking at better than 300 femtoseconds RMS jitter, measured at under 400. So we're very excited about this product. We have it rolled out to a few customers already, deployed on their SoCs, and it's just a matter of time when we move this to different FinFET nodes, such as 12, 16, possibly 3, already in 6 and 7. So another side of our business, we're largely known for our PLLs and clocking solutions. The other half of our business is SerDes, SerDes PMAs, and we have a kind of a platform multi-protocol SerDes that we've been promoting since about 2014 or 15 when we introduced the multi-protocol SerDes to our lead customer, Microsemi, who's now Microchip. We have expanded this SerDes to different platform nodes, which I'll talk about in the next slide. But we're talking about up to 33 gigabits per second data rate and supporting multiple protocols, well over 20 protocols, including PCI Gen 1 through 5, DisplayPort, USB, JSD, a lot of the Ethernet standards. And really great power numbers. We have listed here short reach at less than 5 picojoules per bit, which we can optimize even further. So the kind of high-level summary shot of our multi-protocol SerDes platform. We have the green and blue colors here. Green means that it's silicon proven in customers' hands, in chips out in the world. We have all these different process nodes, 40 nanometer in global and TSMC, UMC 28, and TSMC 12 and 16. The blue bars represent in development. Actually, the TSMC 6 nanometer is a low latency version of this multi-protocol SerDes. That's actually shipped out to 2 lead customers already. And the global 12LP is going to be supporting 33 gigabits per second, or PCIe Gen 5. That also is on a test chip. So the blue is getting very closer to green in both of those cases. All of these are the standards that we're supporting. We don't need to go one by one, but it's a large number of them. And we work with the leading edge, or the leading controller partners for supporting these standards. So we collaborate with them to deliver the PMA and the controller to create the PHY for our customers. Last topic is our foundry support. This is a kind of older slide from our slide set showing all the different foundries we worked with over the years. TSMC is a large foundry for us, of course. If we take all the foundry support we do and have done and are capable of supporting today, we have this list of FinFET, FDSOI, and CMOS process nodes. In the past 12 to 18 months, we've made some strides in supporting Samsung and Intel Foundry Services specifically. So we're supporting IFS 16 at Intel with GDS available today. And in Samsung, we've expanded our portfolio quite a bit, especially in our PLL space at 4, 5, 7, 8, 10, 14, and 28 FDSOI has been there for a while. So in summary, we're providing our innovative IP across very wide range of platforms, all the way down to 3 nanometer, but also supporting markets in planar nodes and other FinFET nodes. And with the vast knowledge and customer success we've had over the years, over 300 customers, over 400 products, we feel like we're a very low-risk choice for what we're calling clocking solutions, not just PLLs, but also IP supporting your clocking requirements and SerDes multi-protocol PMAs. All right, I think that's it. Thank you very much.